In the name of God, hello everyone. My name is Alireza Ghafouri. I'm a master's student of artificial intelligence at the University of Tehran, Iran. My research interest is video recommender systems, and I have some good experiences to be teacher assistant in some master's courses of my university, such as machine learning and deep learning with applications. Okay, let's get started. In section 2, we want to talk about polynomial regression. In previous section, you got familiar with linear regression, which although it is a very good method, but it has a big problem, and it is a strong simplification assumption. And that is a linear relationship between output and input features, which we know that many times it is not true. And we have more complex relationships between X and Y. And here is where the polynomial regression comes to our aids. For example, in such equation, we have not a linear relationship between X and Y. And I want to visualize it for you. For example, consider that we have a random sample that comes from uniform distribution with a size of 30, and we consider it as X, and in Y we use the equation mentioned above. We saw it here. And in this part, we generate a random noise and we consider it for both input and output, and add these noises to them. And at the last part, we try to visualize the data. And as you can see, of course, there's not a linear relationship between X and Y here. So in section 2.1, we want to talk about design matrix. As you know, in regression problems, we want to learn the weights of input features. And because of this, we need a good structure that can represent very well for us the input features. So we define design matrix, and for linear case with only one input feature, we have a matrix like this. Here we can see that the first column is ones, that is for bias, and the second column is for that one feature. And if we want to use in polynomial case, it means polynomial regression, and for example of order k, we have a matrix like this, and here after column of ones, we can see x with power of 1, x with power of 2, and so on until x with power of k. And if we want to use more than one input features, for example, two input features that we can call them xm and xn, we can inject them, no problem, and we can inject them into our matrix. And as you can see here, we have xm with power 1, xn with power 1, and repeat for higher powers until we arrive xm with power of k and xn with power of k. So here we want to implement it. We have a Python function called make design matrix. Its input arguments are x, our input, and order, that is polynomial regression order. And of course, the output of this function is design matrix. So here we start to build design matrix with a column filled with ones, that it is for bias, and then we use a for loop that's for the rest of degrees. And in each iteration of this loop, we create a new column and then try to horizontally stack the previous design matrix with the new x with power of degree in this iteration. And finally, we return design matrix. So here we want to run this function. Because of this, we consider value of 5 for order, and we call this function, and we want to see the first two rows and first two columns of this design matrix, although it has, of course, more than two rows and columns. So here we can see the first column is ones, it is for bias, and the second column is for first input feature with degree of 1. Thank you guys for your attention, and good luck.